In the years leading up to the Second World War, Germans had already come up with what we could freely say was the best machine gun in the world when it appeared. But even more important was the concept behind it. While other armies were still splitting their machine guns into several categories, like water-cooled, air-cooled, light, heavy, anti-aircraft machine guns and so on, the Germans made their MG42 the world's first general-purpose machine gun. By changing mount, sights, or the way it feeds, the same gun could do more or less everything. It could move with the infantry squad as a light machine gun, firing from the hip or bipod. It could be put in an anti-aircraft role in various configurations. If it was on the ingenious Lafette tripod, which we'll come to later, it could work as a heavy machine gun. And of course it could be used in tanks and vehicles, all with one design in the same caliber as the standard infantry rifles, the 7.92 by 57mm Mauser. And on top of all of that, the MG42 was just beautifully built from precise high-quality materials, coupled with the revolutionary quick barrel change system. It had one trigger you could use for single shots by pressing the upper half, or full auto with the lower, and it fired at a rate of some 900 rounds per minute, while all the other machine guns in the world didn't go much over 600. So, why then did Germans start looking for a new machine gun that'd go in almost the opposite direction to the MG42? Well, that high quality and precision were actually the MG34's biggest flaws, and what had started the work on MG42 even before the war began. See, nearly every part of the MG42 was cut out of solid blocks of high-grade steel on machine tools, which had to be done by skilled workers with very tight tolerances. It took about 150 man-hours and about 100 pounds of raw steel to make one 25-pound machine gun. And to add insult to injury, those tight tolerances, so typical of the German engineering mindset, turned out to be horrible for battlefield conditions, where the machine gun was supposed to work. You see, the tight tolerances mean that the parts are allowed to vary in dimensions by just fractions of a millimeter, or thousandths of an inch. This makes the moving metal parts fit together almost perfectly, which in theory would mean that the gun would work without flaws. However, there's so little space between the parts inside a gun that when something like dirt, sand, carbon buildup, or thick lubricants gets inside, these parts jam up and the gun doesn't work. This is why even the most modern military firearms intentionally use slightly looser tolerances, and why you see the AK-47 working even when dipped in mud. And the Germans found that out the hard way when their high-quality machine gun went into the desert of North Africa and the Eastern Front. Not only did they have a machine gun that was extremely expensive and slow to mass produce for a global war, but it also didn't work well on the battlefield if not religiously cared for and kept clean. And all that despite truly being beautifully engineered. Before even realizing the problems this precise machining would cause in the conditions of the desert or the frozen east, the Germans went looking for a way to make a new gun in the same caliber that would be much cheaper and faster to build, and to also have an even higher rate of fire, which I'm going to explain as well. A company producing household goods, shaping sheet metal by pressing and stamping techniques, was then contracted to make the machine gun. This was strange to everyone, including the designer Dr. Werner Gruner, who knew nothing about machine guns, so he signed up for a machine gunner's course. He saw firsthand how the machine gun was supposed to work, talked with the soldiers, and learned everything he could from their battlefield experience about what makes a good machine gun. He then took an existing operating system developed at Mauser, that roller lock idea, and paired it with something that went completely against what most people thought made a good machine gun. Step by step, they came up with what would be adopted by the German army as the MG42. The body was pressed out of sheet steel about 2.5 millimeters thick, joined by spot welds and rivets. Only the barrel, bolt, and a few locking pieces were milled from solid steel, instead of a whole machine gun like the MG34. This weird, cheap-looking, wobbly, loose tolerance weapon just gave the old-school engineers a heart attack. But the payoff was huge. The production time and the amount of steel needed per gun were literally cut in half, which also avoided the alloy steels that were becoming scarce in Germany. And on top of that, the looser tolerances that had to be used with the stamped design turned out to make the gun much more reliable when fired without oil, when dirty, across temperature extremes, or anywhere the high-quality MG34 would stop. It fired from an open bolt, which let the air flow through the open barrel, and helped cool it off between bursts, and also prevented the cook-offs that happen when the round is sitting enclosed in the hot chamber. While the MG34's bolt had to rotate to lock and unlock, with the MG42, nothing turns. And everything moves in straight lines due to that roller lock system. This keeps things simpler, with much less friction, which was important at such a high rate of fire. The MG42 went into combat with Afrika Korps alongside the MG34, and soon deployed fully on the Eastern Front after earlier combat testing. And of course, that extremely chewed-over rate of fire was now between 12 and 1500 rounds per minute, which we have to address immediately. Another thing that helped with such a high rate of fire was the belt feeding system. This is the part of the MG42 that got copied by almost all other designs we have today. You see, during firing, the belt is pulled in two half steps. It moves half a cartridge width while the bolt goes back and the other half while the bolt goes forward. So, instead of one big yank per shot, this lets the feed stay smooth and keep up at the rate that would tear other feed systems apart. Put all of this together and you get the gun that fires between 20 and 25 rounds per second. But why this fast, when Allied machine guns fired at half that rate? Well, first thing is that the 1,200 rounds per minute is a laboratory number, meaning how many rounds the mechanism can cycle in 60 seconds. If the trigger is held down, the belt never ends and the barrel can't be destroyed. In practice, German gunners were trained to fire only in short bursts of 5 to 7 rounds, then wait, aim and fire again, making about 20 such bursts per minute. And of course they had to change barrels and belts. So the practical rate of fire was some 150 to 200 rounds per minute during the active engagement, after which the barrel should be changed. The German idea behind such a high rate of fire came down to how machine gun fire really works. When a burst is fired, every round leaves the barrel on a slightly different path because the gun vibrates, the mount flexes and all that. The bullets spread into a narrowing and then widening funnel in the air, which is called the cone of fire. And where that cone hits the ground, it makes an elliptical patch called the beaten zone. So, anyone inside that beaten zone has a high chance of getting hit. And the gunner is not really aiming at a single enemy soldier, but he's covering a stretch of ground with the spread of the burst. This means that the wider beaten zone, which would mean a more inaccurate weapon, was actually deadlier when paired with an extremely high rate of fire. That wider spread with more rounds, logically, raises the chance of hitting something fast-moving you don't want breathing anymore. On a flat or evenly sloping ground, the machine gun team could use what's called a grazing fire. This is when the center of that cone never rises more than a meter above the ground, which means anyone down that line is going to get hit for as long as the terrain stays flat. Add to that the fact that the Germans made their machine gun positions crisscross their fields of fire, and you get the killing zones the Allied soldiers were walking into during World War II. Germans always made several alternative machine gun positions, to which they'd move when their first position was compromised. They'd fire from one spot, hit someone, make the others hit the ground, and then as soon as the enemy worked out where the fire was coming from and started answering with tanks and machine guns, the German team would quickly pack up and move to the next position. Allied soldiers then started their advance again, thinking the machine gun was knocked out, only to receive fire from a different angle. This is also why they thought the Germans always had more machine guns than they actually did. So, you now see that the real reason why the German machine guns were so feared and deadly was not just the rate of fire and the buzzsaw or tearing cloth sound that is so much chewed over in a bunch of AI slops spamming YouTube. Anyway, firing about 500 rounds with one barrel in quick succession could be enough to wear the barrel beyond use. If used correctly, the barrel lasted about 4,000 rounds, with late-war hard-chromed bores pushing that up to 8,000. But of course, if you have a massed infantry attack coming at you, you're not really going to follow such a procedure, but rather hold that trigger down until you run out of ammo or something breaks on the gun. The barrel change system was very different from the MG34's, and it was built for speed and field use. The gunner unlatches a flap on the right side of the barrel jacket, and the rear of the hot barrel swings out sideways through the opening. It's pulled out, and the fresh barrel goes in, and the flap snaps shut. This could be done in just a few seconds by a well-trained crew. So that advice to the Allied soldiers, to use this window to advance, would give them enough time to barely move a few yards before the MG42 started firing again. The MG34, on the other hand, had a barrel change system where you had to unlock the receiver, swing it to the right, and pull out the barrel from behind the gun. And this is why the MG34 stayed in parallel production through the entire war, and was the main machine gun for use in tanks. You couldn't use the MG42 from inside a tank because of that system. At least not without redesigning the tank. But besides that, there were already thousands of MG34s in various configurations, so Germans still had to produce the spare parts. Also, retooling the factory from MG34 to MG42 production took time that would mean a pause in production, and they simply couldn't afford that. So, the MG34 stayed in production together with its younger brother all the way till the end. But not everything was so great about the MG42. There was something no one talks about that was happening often enough to start an investigation, and that was MG42s blowing up in their gunners' faces while firing. It turns out that during firing, the moving parts were oscillating and bouncing around by up to a millimeter, which could cause out-of-battery ignitions, meaning the round would be fired before it was fully closed in the chamber. The wartime solution was to make special extra sturdy ammunition with slightly slower primers and use it only with the MG42s. Now, my favorite thing about the German World War II machine guns is the Lafette tripod. This thing works just the same with both the MG34 and 42. It turns them into a heavy machine gun and unlocks their full death potential despite being the very same weapon. The Lafette has spring buffers that absorb the recoil and make the fire more accurate and controllable, but it comes with some outright ingenious features, and I don't get why we don't have them today. The tripod had a telescopic sight, which significantly extended the gun's effective range up to 3,500 yards. When fired indirectly like an ultra-light artillery piece, it could be used this way to deny the area to the enemy or to harass the rear units. But this configuration was the most dangerous when used in ambushes. And that's because of the thing called Tiefenfeuerautomat, a mechanical device that used the gun's own recoil energy to walk the fire up and down the range set by the gunner. For example, if the gunner couldn't tell whether the target was at 2,000 or 2,500 yards, he'd set the sweep for 19 to 2,500 yards. Then, as long as the gun fired, the device moved the fire across that zone in waves, dragging that beaten zone we talked about earlier back and forth over the area. The machine gun could even be mounted inside the trench and then aimed through the telescopic sight so the gunner didn't need to expose himself to return fire. The whole setup sat low to the ground, and it was much more difficult for the enemy to find where the fire was coming from, and then to knock the machine gun out. The gunner fired through a trigger handle without touching a vibrating gun that would affect his aim. But this also meant that he could tie a string to it and fire it across the prepared zone with that mechanism, without being beside the gun. Nothing like this existed in any other army in the world, and it was an extremely expensive and complicated device. It cost the same to produce as about 2 MG34s, but in the right hands and in the right position, these mounts were among the deadliest weapons against the infantry. As for the other details about the German World War II machine guns, it's fascinating how far their thinking went when they were designing these things. They had the drums, holding 50-round belts that would serve as the ready ammo, while the cans held 5 50-round belts connected into one. The belt was non-disintegrating, and during the war the Germans redesigned it in thinner steel, which saved a third of the metal and unexpectedly worked better with the guns. Ammo cans were watertight, with the handles positioned closer to one side, so 2 could be carried in one hand. The handles could also be folded down, so the cans could be stacked one on top of another in tight places like inside a tank or a bunker. Allied armies never thought about this with their equipment, whether we like to admit it or not. While the Allies had their machine guns there to support the infantry, the whole German squad was organized the other way around, with the infantrymen working around the machine gun. There were 6 riflemen, armed with the standard Kar-98 bolt-action rifles. Then a 3-man machine gun team of a gunner, assistant and ammo bearer, each with a pistol as a sidearm, and the squad's commander, usually an NCO, armed with the MP40. Riflemen worked around the 3-man machine gun team, so they protected it, of course helped carry the ammo, and advanced under the machine guns covering fire. Germans also deployed more machine guns for the same number of soldiers, so the Allied soldiers were almost always running into MG34s and 42s. Americans turned this idea around and gave each rifleman more firepower than the German riflemen, as the M1 Garand was the only standard service 8-round semi-automatic rifle in World War II. Compare that to the bolt-action 5-shot Kar-98 of the German soldier. And of course there were the Thompson and M3 submachine guns, the Browning automatic rifle, and then M1919 and M2 Browning 50 caliber as the heavier weapons. This way the firepower is more dispersed, and the American squad doesn't risk losing its main and only source of heavy automatic fire if one machine gun is knocked out, as would happen to a German squad. However, we have to admit that if you compare the German and Allied machine guns pound for pound, nothing comes remotely close to the ingenuity Germans put into their weapons. And don't get me wrong, all those chewed over facts about the MG42 that I'm so allergic to are mostly true. It did cause enough fear that the US Army treated it as a problem in itself. This is why they made that famous quote-unquote training film that, absolutely not for propaganda purposes, compares American and German automatic weapons. They showed how the MG42 barks worse than it bites, and how the German weapon was wasting ammo on inaccurate bursts and would quickly overheat. Meanwhile, the Americans had more machine guns that fired slower and more accurately, which made them more effective. German machine guns were deliberately downplayed, but I imagine that anyone unfortunate enough to find himself under fire from them would probably disagree. And if the MG42 wasn't as good as the training film showed, why did the Americans then try to copy it? That was the T-24 project, when they tried to build the MG42 chambered for the American 30-06, and with a heavier bolt to slow down the rate of fire. But the project died because the 30-06 cartridge case is 1/4 of an inch longer than the German 7.92 by 57 Mauser case, so the prototype couldn't fire reliably. So, after 51 malfunctions in 1,583 rounds, the project was abandoned. However, many features of the MG42 were copied, like the belt feed system and trigger group, which ended up in many famous machine guns such as the American M60 or the FN Mag. As for the Germans, although they lost the war and were forbidden to have an army, a few years went by and in 1955, the Bundeswehr was formed and joined NATO. But when they looked around for what machine gun to standardize for their troops in the now universal 7.62 by 51 NATO caliber that all alliance nations agreed to use, they realized they already had something familiar that worked great just a few years ago. So they took their good old MG42 and rebuilt it for the new cartridge, though they had to somewhat reverse engineer their own design, since Rheinmetall had to start production from scratch after their best engineers and blueprints were seized at the end of the war. But anyway, this is how the MG3 was born. Pretty much the exact same design as the MG42, just in a new caliber and with heavier bolts that could slow down the rate of fire to some 900 rounds per minute. It would spread to more than 40 countries and is still in service to this very day.